So for today, let's talk about the Spearman rule. So what is the Spearman rank correlation or the Spearman's rule? The Spearman rank correlation coefficient is the non-parametric version of the person correlation coefficient. So non-parametric means do not require a distribution because in person correlation coefficient, the data is not normally distributed. So assumption for Spearman's rank correlation. Your data must be ordinal, interval or ratio. It means that it must be ranked in a sequential order. Interval is the gap and the ratio means a relationship. So because Spearman's measures the strength of a monotonic relationship, so monotonic has to be monotically related. So this means that if one variable increases, the other variable also increases or decreases. So measures the relationship between two continuous interval or ratio scale variables. So the Spearman correlation is used when measuring the relationship between two ordinal variables and measuring the relationship between two variables that are related but not linearly. So the Spearman, this is the test result of the Spearman's return a value from -1 to 1, where the 1 is a perfect positive correlation between ranks, and -1 is a perfect negative correlation between ranks. And if it is 0, so this means that no correlation between ranks. Spearman rank correlation work example. So this is for no-tied ranks. So the formula for the Spearman rank correlation coefficient when there are no-tied ranks is P is equals to 1 minus 6 and the summation of D squared divided by the n and multiplied to n squared minus 1. So we have there the example question. The scores of 9 students in physics and math are as follows. So physics 35, 23, 47, 17, 10, 43, 9, 6, and 28. So we have 9 score in physics and 9 score in mathematics. Compute the students' ranks in the two subjects and compute the Spearman rank correlation. Find the ranks for each, step 1, find the ranks for each individual subject. So you can use the Excels to rank these scores in an easy way, or you can do it by hand. So you need to order the scores from greatest to smallest. Assign the rank from first to the highest score and 2 to the next highest and so on. So we have there. So as we see, 47 is in the highest and 9 is in the low, 6 is in the lowest. In mathematics, we have 49 is the highest and 4 is the lowest. So rank this. How to rank this one? So since 47 is the highest, you rank it first. Then 43 is the next. 35, 28, 23, 17, and then 10, 9 and 6. That's how you are going to rank this. So step 2, add a third column. So this one, the d squared. And next is the d or the difference and d squared, or the square of the difference. The D is the difference between ranks. For example, the first student's physics rank is 3 and math rank is 5. So the difference is 3 points. In the fourth column, square your D squared. So this is the difference as I've said, and this is the square of the difference. So in getting this one, you need to subtract this first rank to the second rank. So 3 and 5 is 2, 5 and 3 is negative 2, 1 and 2 is negative 1, 6 and 6 is 0, and so on and so forth. And d squared, so you are this one, so square this difference. So this one, 2 squared is 4, 2 squared is 4, 1 squared is 1, 0 squared is 0, and so on and so forth. And then next is add up all your d squared values, so sum. So you need to add all your d squared because we are going to need the sum of the d squared in answering the formula of the Spearman rule, the Spearman correlation curve. So after that, insert the values into the formula. These ranks are not tied, so use this formula. So this is for the 9 not tied, or ranks are not tied. So 6 times 12 divided by 9, and then 81 minus 1. So 6, and this, since the sum of our d squared is 12, so put the 12, then divide. So we have 9 squared, then 9, then 9 squared is 81 minus 1, and then 1 minus 72 over 720. So 6 times 12 is 72, and then 81 minus 1 times 9 is 720. So now 1 minus 0.1 and equals to 0.9. So the Spearman rank correlation for this set of data is 0.9. So it is a perfect positive correlation between ranks. So next is, what if there is a tied rank in our data? So what to do if there is a tied rank? So tied ranks are where two items in a column have the same rank. Let's say two items in the above example type for rank 5 and 6. The following image shows each type data point assigned a mean rank or 5.5. So if we're going to rank those 9 scores, the physics and mathematics, the physics we have this rank, and then the mathematics is tied on the first and the fourth column. So we have 6 and 6 here. So in Spearman rank correlation, this cannot be, so we need to adjust this one, or the adjust rank to 1, 2, 3, 4. So we have 5 and 5. So 5.5 and 5.5. So we don't need to put 6 because this is considered as 5 and 6. So we need to 7, 8, and 9. So this squared. Oh, no. the difference. So the difference of this rank. So in this situation, the difference of the first rank and the adjust rank. So we have negative 2.5, then 5 minus 3 is 2, 1 minus 2 is negative 1, and so on and so forth. So square this one and we get this one. And then sum of all the d squared. So we have 14.5. So case of tied ranks arise when two or more individuals have the same rank. Each individual is assigned a rank equal to the mean of the ranks that would have been assigned to them in the event of there being slight difference in their values. So no change would be made in the ranks of other values. Since the Spearman's formula is based on the assumption of different ranked different individuals, in case of tied ranks, its correction becomes necessary. So we have the correction factor. We have the correction factor formula. CF is equals to m squared multiplied CF, or the correction factor, is equal to m multiplied to m squared minus 1 divided by 12. So, where m denotes the number of observations tied to a particular rank, then this CF is added to the sum of d squared once for every type. So this is you can use this if there is a type. So if there is two types, you can use this. 3, 4, and so on and so forth. You can use this one. As positive Spearman correlation coefficient corresponds to an increasing monotonic trend between x and y. A negative Spearman correlation coefficient corresponds to a decreasing monotonic trend between x and y. So this is the graph. This is how you graph that. This is the positive increasing and the negative is decreasing. So I have there the quiz. So this is my quiz. So find the Spearman correlation. Physical activity has any correlation to our blood pressure. In column B, we have the number of minutes that 10 men of the same age spend daily in gym. And in column C, we have their systolic blood pressure. So we're going to solve this one. So kayo na ang mag-solve nito. And then this is all about Spearman's rule. This is the end of my report. So since I cannot use Excel at the same time, so I'm going to make another video for I'm using Excel and solving this question or this example here. So I have a second video. This is for my report and goodbye.